Hey everyone, we're going to continue today with our exponential solving worksheet. So ideally yesterday we completed page 1, which should have worked our way kind of through some of these problems. I did another one here just kind of as an example, and I might be uploading the complete answers with these notes at some point. But otherwise it should have been relatively straightforward, basically trying to isolate the exponential however we need to, and then using that in order to get to our graphic organizer and figure out what that is. So I guess I can run through another example here real quick. So I would divide both sides by 9 in this case, and I believe, let's see, 225 divided by 9 gives me 25. And then from here to here, it's currently just a thought process of, okay, 5 to the what power is going to give me 25. If we have that graphic organizer, we can use it, but we also might be able to see that, okay, if x is 2 in this particular case, then I'm going to get 25 as well, because 5 squared is 25. All right, so this allows us to kind of solve some of these, including situations, this real world problem situation that we have, which I'm going to take a look at one of these on the next page, and then we're also going to be able to learn about logarithms, which allow us to solve more complicated exponential equations. So here's an example of an exponential situation. So we have our phone tree again, starting at 4 coaches, calling 5 players each. So here is our a times b to the x equation, or 4 times 5 raised to the x power. And I just chose that, I think, is like players, and x is just kind of our typical steps or iteration variable that I chose here. So my first question is one that we should be able to answer with relatively straightforward solving practices. So here, if I divide both sides by 4, 625 equals 5 to the x, which we have on our organizer, so that's just going to end up being x equals 4. And that's because 5 to the 4th power is 625. But I arrive in this interesting situation on this next problem where if I have to figure out how long it's going to take for 10,000 players to be contacted, this is the equation that I'm attempting to solve. I can divide both sides by 4, divide both sides by 4. 2,500 equals 5 to the x. And if I try to figure out what this is, either mentally or on my graphic organizer, it's a little bit tricky. So I have 5 to the 4th is 625 from above, and then, if I just do 5 to the 5th power, then I get 3,125. So already I'm a little bit over, and I should be able to see that somewhere in between 4 and 5 is going to be my x value. But in order to get more accurate than that, then I have to introduce logarithms in order to get there. So taking a look, logarithms allow us to rewrite exponential functions. And this is kind of our big rule for rewriting exponentials as logarithms. And you can see kind of part of the takeaway or the value here is that often my variable, which is in the exponent, can be rewritten so that the logarithm is just set equal to it, which makes my life a little bit easier. So the first things we're going to practice here is just flipping back and forth between forms. So I'm going to show you something that's in exponential form, and then we're going to write it as a logarithm, and then we're going to do the opposite. So if something's a logarithm, we're then going to write it as exponential. So first, exponential to logarithm. So 2 to the 4th equals 16. So basically I'm starting on this side, and all I have to do is recognize, okay, what are the a, b, and c values, and how do I need to put them in the appropriate position for this. So here, this is going to be log base 2 of 16 equals 4. Okay, and we know all the variables there. I mean, there's really not any variables left. That's just a true mathematical statement that the log base 2 of 16 is 4. And, 2 to the 4th is 16. Those two kind of go hand in hand. So here this would be log base x of 144 equals 2. Another which way of kind of rewriting this. Obviously, if I was looking for x, it might be more beneficial to have that written as an exponent or a x squared equals 144. A little bit easier, but this is again just a conversion from one form to the other form. 3 to the x equals 81, which means log base 3, 81 equals x. And this is probably our most common case where you would use a logarithm, because in theory I know everything on the left-hand side, and I'm going to show you how your calculator can calculate that value. And the only thing that I'm missing is already on the right-hand side. So this is kind of better to be here where my variable's isolated versus here, because I don't really have anywhere to go from there except to complete basically a logarithm of both sides. All right, now we're going to take the opposite direction. And this one, visually, I have an easier time with because I generally just look at this and I say, okay, that means 4 squared is 16. You can still follow the organized formula above, but this one I just for some reason have an easier time visualizing. So 2 to the x equals 32, x squared equals 25. So this is just converting back and forth between forms. And again, looking at this, we might think, wow, I have no idea what x is going to be in this case. But when I write it as x squared equals 25, the majority of us could probably say, oh, well, that's just going to mean that x equals 5. All right? So converting back and forth between forms is going to help us isolate our variable when we need to. It brings it out of the exponent, which is the key, and then we can use it in solving, and I'm going to show you how to do that right now. So if I have to solve an equation like this, or in the situation where I had the football players, I can use my basic solving strategies just to try to get 6 to the x power by itself first. So I'm going to divide both sides by 7. So here I got 182.85. I'm only going out to the hundredths place here, but we've isolated our exponential. Now I'm going to rewrite this so that it is in logarithmic form. So that's going to be log base 6 of 182.85 equals x. All right, everything on the left is a known quantity. And on the right-hand side, we have our variable. So at this point, we just need to learn how we're going to plug this into our calculator. And there's some slight trickery to this that we're going to be talking about in our next lesson. But for the immediate kind of intents and purposes, we can just say that in order to evaluate this, you're going to do log of 182.85 divided by log of 6. And those would just go into your calculator. So this is equivalent to this statement right here. And the nice part is that my calculator has all of those buttons. Your phone should as well. So if I just type those in, log 182.85 divided by the log of 6, end up getting 2.907. So x equals 2.907. So if I were to just test that out for reasonableness, we know that 6 squared is 36, so that would be a 2. 6 cubed gives me 216. So if I am trying to thread the needle and hit this 182.85, that has to be 6 to the 2.907 is what we just found out. So we were able to calculate that exponent. This gives us a lot of power to be able to answer not only just the more difficult, but also the more realistic exponential situations that we would be coming across. So City population starts at 10,000. That's our starting point, or our A value. City is growing at a rate of 3% per year. So this is going to be 1.03. And then, so this is my basic equation right here. All right, that's my standard equation. After how many years will there be 11,000 people? So now I'm trying to figure out this equation. So no different from the equations we were starting with, I'm going to start by trying to isolate my exponential, which is this, and that amounts to dividing by this 10,000 on both sides. And then I'm going to rewrite this as a logarithm. So sometimes it's a little choppy to keep working on that same line. So sometimes I'll do an implication to say what this means. So this would mean that the log 1.03 1.1 equals t is my conversion. So this entire statement rewritten as a logarithm would be log base, so this is called a base, of 1.03 of 1.1 equals t. And to evaluate that, again, if I'm using that rule above, I do log of 1.1 divided by log of 1.03. So essentially take the log of this top number and then divide it by the log of that bottom number, and that's going to tell me my answer. So log 1.1 divided by log 1.03, and I end up with t equals 3.22. So if a city's population is growing exponentially, starts at 10,000 and is growing at 3% per year, then after 3.22 years, there'll be 11,000 people. So using logarithms allows us to solve those exponentials that previously we weren't able to. And the primary usage of it is that it takes the variable that was an exponent and brings it into a more mathematically appealing location where we can actually manipulate it and or figure out what it is. There is a collection of problems on a worksheet that you're going to do to kind of practice this. Some of them, I believe, are in a problem situation, and others are going to be this kind of straightforward process here where you're going to isolate the exponential and then solve using logs after that. All right, thanks.